The May 2018 AS paper, question 9. So we've got a function g of x, 4x cubed minus 12x squared minus 15x add 50. And part A asks us to use the factor theorem to show that x plus 2 is a factor of g of x. So for part A, we know that if x add 2 is a factor, that means that x has got to be equal to minus 2. So therefore we sub minus 2 into g, and that's going to give us 4 lots of minus 2 cubed, minus 12 lots of minus 2 squared, minus 15 lots of minus 2, add 50. Putting that into the calculator, we'll see that the answer is 0, and we can say therefore x add 2 is a factor, fairly straightforwardly. Part B. Hence show that g of x can be written in the form g of x equals x add 2 brackets x ax add b all squared, where a and b are integers to be found. So now we know that x add 2 is a factor, we can use algebraic long division. We can put x add 2 into 4x cubed minus 12x squared minus 15x add 50. So the first stage is we look for the highest power of x inside, so 4x cubed, and we divide that by the x. 4x cubed divided by x is going to give us 4x squared. We then multiply the 4x squared by the x, gives us 4x cubed. Multiply the 4x squared by the positive 2, and we get plus 8x squared, and that gets subtracted. So 4x cubed minus 4x cubed is 0. Minus 12x squared minus plus 8x squared will give us minus 20x squared. And we bring down the next part, minus 15x. The larger power of x on the inside is now here with the minus 20x squared. Minus 20x squared divided by x is minus 20x. Then we've got the multiplication side, so minus 20 times x will give us minus 20x squared. Minus 20x times 2 gives us minus 40x. And this is subtracted. So minus 20x squared minus minus 20x squared is 0. And minus 15x minus minus 40x will give us 25x. And then we bring down the 50 plus 50. 25x divided by x is plus 25. 25 times x is 25x. 25 times 2 is 50. And we have a 0 remainder on the bottom there. So what that leaves us with is our g of x function is equal to x add 2 lots of 4x squared minus 20x add 25. And so x add 2, and by factorising the second part, we're going to get 2x minus 5 all squared as our solution for part B. Part C1. Use your answer to part B and the sketch to deduce the values of x for which part 1 g of x is less than or equal to 0. So by looking at our sketch where g of x is less than or equal to 0, we've got less than 0 in this part here, and we've got equal to 0 at that solution there. So looking at our answers, we've got one bracket of x add 2 and one of 2x minus 5. So that means this solution here is going to be 5 over 2, and this solution here is going to be minus 2. So from there we can say that the function is less than or equal to 0 when x is less than or equal to minus 2, or when x is equal to 5 over 2. Part 2, where g of 2x is equal to 0. So that is a transformation. So g of 2x is equal to 0. The transformation is inside the brackets, so it affects x, and it does the opposite. So therefore we had it equal to 0 when x was minus 2. We halve that to now be where x is minus 1. We had it where it was 5 over 2. We halve that, and it's now 5 over 4 for our two solutions there.